Hello, geometry, and welcome to Unit 11, the last big unit that we're going to do. There is a Unit 12. I don't even know if we're going to get to it this year. So here we go with Unit 11. This first one is kind of weird, but then after that, you're going to see some patterns kind of take shape. So definitely an introductory lesson here. Identifying faces, edges, and vertices of a polyhedron and tell how many of each there are, and then sketch a polyhedron from a net and a net from a polyhedron. So there's some vocab in there, which makes sense in an intro video. But in this unit, the whole unit, not just this lesson, we are dealing with three-dimensional shapes. Everything up until now has been two-dimensional. We are moving into the third dimension with this lesson and with this unit. I've already said this in the learning targets, but a polyhedron is a three-dimensional figure whose surfaces are polygons. So we've talked about polygons. We've had lots of polygon lessons. Triangles are polygons, quadrilaterals, pentagons, hexagons. We've talked about all those. Okay. Now there's some other vocab. A face of a polyhedron is a surface of the polyhedron. Okay, so one of the surfaces. And again, that surface is a polygon, like I just said. And again, you'll see examples of this as we go. An edge is a segment formed by the intersection of two faces. So an edge is a segment formed by the intersection of two faces. Okay. A vertex is a point where three or more edges come together or intersect. All right. And then the last vocab word that I want you to see with this lesson is a net. So a net is a two-dimensional. So I'm just going to put 2D for two-dimensional pattern that you can fold to form a three-dimensional or 3D figure. You'll see an example of a net here pretty soon, a very basic example of a net. So those are the vocab words that you need to understand. All right, so the most basic of the polyhedron is a cube. You've seen cubes. Why is it a cube? Because its faces are all squares. So we're going to use the basic polyhedron to identify the three types or the three parts of a polyhedron. So the face, edge, and vertice. So a face is, again, one of the sides or one of the surfaces of the cube. So that would be this one. This is a face. What that's pointing to is a face. Where two faces come together is an edge, and that one is this one. And then where three edges come together or more, in this case it is three, that is a vertex. Okay. And I just said we'd be doing a net. The most basic of the nets is right here. That is a net. If I would fold that up, I would make a cube. Most of you can probably see that happen. Put the 3 on the bottom. The 2 and the 4 would be the left and the right side. The 1 and the 5 would be the back and the front. And the 6 would land on top, right? If I would fold that up. Now, the question is, which faces would be opposite one another in the cube? Well, if you just heard me there, the bottom is 3 and the top would be 6. So 3 and 6 would be opposite each other. 2 is left, 4 is right. So 2 and 4 would be opposite each other. 1 and 5 would be back and front. So those would be opposite each other. All right. Notice that opposite faces cannot share any sides. It's like 3 and 6, there's nothing in common. They don't have anything shared. 1 and 5, same thing. Okay. Now, does that mean every piece of that, so like 2 and 6 don't share a side, does that mean they're opposite each other? No, because when 6 gets folded in, it will share a side with 2. Okay, so you're going to have some work with that on the worksheet, but that's not too important. I just want you to see it. So we're gonna do the same thing here. I'm gonna kind of fold this up. It's gonna make like a tent-like thing. So I'm gonna have a triangle. I'm gonna put the triangle in front, and then I have 3 rectangles. Here's one. The bottom is another one. And then the top, or the left side is the 3rd rectangle, and then the triangle in the back. So the left side, top left side, top right side, and then the bottom are all the rectangles, and then the 2 triangles are in the front and the back. So that is turning a net into a polyhedron, or in this case, it's a prism, which we haven't talked about yet. We're going to go the other way as well. So that's what the next question is asking you to do, is go the other way. That one is a polyhedron. A pyramid is what it's called. We want to draw a net. So imagine I could unhook that. Say all those points were held together with a hook, or a pin, and I pulled that pin out. What would happen? Well, all of those triangles would fall down. At the bottom right now is a square. So I'm going to start with the square in the middle. And what's going to happen is you're going to get 4 triangles that plop down. All of them share a side with the square. So it's going to look like this. Okay. And there's your net. Another example of that. You could break this one a bunch of different ways. I'm going to make this one look like the one in the front, but I'm going to cut it. Imagine I'm pulling a pin here and here. So that front side is going to fall down. One thing I do want you to see is I want you to label this one. So I'm really going to make you look at what's where. Start getting an idea of shape, where this stuff's all kind of landing. So I'm going to start with the bottom. It's an easy place to start. The bottom is a longer rectangle that is 10 by 2. Not sure why the 2 is not writing. That's weird. 10 by 2. Okay. The front falls down. So I'm going to make the front fall down. Still 10. But that top to bottom distance there is the left side of that rectangle. So that's 3. Okay. Well, what's going to fall down on the other side is the back side is going to fall. So the back side is going to fall and do that. And then the top's going to fall at the very, very end and do that. And these are all 10. The back side, the back rectangle there has a length of 3. So that the 3 goes. And then the top one has a length of 2. Now that's only 4 faces. What about the left and the right? Well, I'm going to just have them fall with the bottom. So the bottom was this one. And that was 2. So that makes this 3. And the same thing on this side. And hopefully you can see that. There are other ways of doing this one. Doesn't have to look exactly like that. But I want you to see kind of where stuff lands. All right, almost done with these notes. We're going to move on to something called Euler's formula for polyhedron. And what this does is it relates the number of faces, edges, and vertices. And what the formula says is F plus V equals E plus 2. So F, V, and E just stand for faces, edges, and vertices. So faces plus vertices equals the number of edges plus 2. So first example is pretty basic. A certain polyhedron has 24 faces and 30 edges. How many vertices does it have? Plug them in. So 24 faces. You're looking for how many vertices. So that's X. 30 edges plus 2. So 24 plus X equals 32. And X equals 8. And that would be 8 vertices. Okay, the next one's a little trickier because uses some algebra. So a certain polyhedron has twice as many edges as vertices. So how many edges and vertices does it have? If there are 11 faces, I'm going to set my vertex as X. So the number of vertices equals X, right? It says twice as many edges as vertices. So there's more edges than vertices. How many more? Well, if I double the number of vertices, so double X, I get the number of edges. That's the relationship you need to see. If I double the number of vertices, I get the number of edges. So let's go to the formula. F plus V equals E plus 2. Well, F is 11. V, we said, was X. The E, we said, was 2X. Okay, so that a little more complicated equation, but you should still be able to do this. Subtract 2, you get 9 equals X. So X is, again, the number of vertices. So it's got 9 vertices. And the number of edges is twice that. So 18. You can plug those numbers back in, and that should work. All right, so again, there's your introductory lesson. The next lesson, we're going to get into surface areas of prisms.